In this example, quadrilateral ABC has the given vertices. Show that ABCD is a trapezoid and determine whether it is an isosceles trapezoid. Okay, first thing we have to do is graph the points. Point A is at 5, 1. Remember, you run before you jump when you graph points. So go start at the origin, count to the right 5, and up 1. Put a dot. That is point A. Point B is -3, -1. Left 3, down 1. Here's point B. C is -2, 3. Left 2, up 3. There's point C. And point D is 2, 4. So right 2, up 4. And here's point D. And then we want to connect the dots. A to B, B to C, C to D, and D to A. Okay, so first of all, let's first establish that we have a trapezoid. In order to do that, I need to ensure that I have one pair of parallel sides. So I'm going to have to find the slope of the sides. Now, I don't really need to waste my time. I graphed this, so I know what sides look like they're parallel and which sides don't look like they're parallel. I want to check, obviously, C to D and BA look like they're probably parallel. So let me count the rise and run from C to D. So I go rise 1 and run 1, 2, 3, 4. So this has a slope of 1/4. This is the slope. Let's now count the slope from B to A. I have to go up 2 and write 1, 2, 3, 4, 5, 6, 7, 8. I have to go up 2, write 8. This is again the slope. Now if I simplify that fraction, I get 1/4. We have the same slopes for those two, so indeed I do have a trapezoid, one pair of parallel sides. Okay, now if I want to see if it's an isosceles trapezoid, I need to check its diagonals. So I want to check the distance from B to D and the distance from A to C. Okay, now distance formula when I have it graphed is easy. I can count the slope of the line, so I can look at the rise and run of the slope and use those as my legs of my right triangle to calculate distance. So starting at B, I count to go from B to D, count the slope. I go up 1, 2, 3, 4, 5. So I go up 5 and right 1, 2, 3, 4, 5. So I go up 5 to the right 5 to go from B to D. So for BD, the distance would be the square root of 5 squared plus 5 squared. That is 25 plus 25. Remember, you have to square before you add. Now that is the square root of 50. Now 50 is not a perfect square, so I just leave it in radical form like that. Now I need to check from C to A. Again, I start at C, and I have to count down 2 and to the right 1, 2, 3, 4, 5, 6, 7. So C to A would be the square root of 2 squared plus 7 squared. Now 2 squared is 4, and 7 squared is 49. 4 plus 49 is 53. Okay, do I have an isosceles trapezoid? If I did, these two numbers would be the same, but they're not. So this is a trapezoid, but it is not isosceles.